Now let's take a look at where we get data. We live in a complex society in which data is being collected from a number of different sources. We can collect data from YouTube, from social media sites such as Instagram, Twitter, and Facebook, point of sale systems, healthcare claims data, healthcare devices, you name it, we'll be able to collect the data from it. These will get stored into a database, generally, and then from that database and from that data, we will do analysis and insights. The data can be collected in any form, such as video, audio, and even free-form text. The storage required for these types of data is significant. When we collect complex data, not just tabular data like you might see in a spreadsheet, but complex data like video, audio, and text, it will take up more storage on computers. And the magnitudes of data are in the gigabytes, which is 1,000 megabytes, terabytes, which is 1,000 gigabytes, petabytes, exabytes, zettabytes, and yottabytes, not to be confused with Yoda from Star Wars. There are two categories of existing sources of data. Data in these sources are collected from systems in the previous slides. However, we can consider them as either internal or external sources. Internal sources come from systems that collect data within the organization, such as claim systems or point-of-sale systems. External sources are data that come from sources outside the organization and are used in conjunction with internal sources to provide greater insight, such as collecting stock information from, say, Bloomberg, or collecting weather information from the National Weather Service. These could be used in conjunction with any other analysis to truly create additional value in the machine learning, artificial intelligence, or other algorithms that are produced. In cases where existing data from internal or external sources doesn't provide a way to answer the question being asked, well, we can collect data in a number of other ways, through an observational study or even an experiment. If we wanted to examine foot traffic of students coming into the Star building here at Hofstra University, we could conduct an observational study. We'll literally have someone sit at a door and count the number of people that are coming in at any particular time. So an observational study is a process by which data is collected by observing the entities being studied. We may count the number of people coming in on a particular hour over the series of hours over the number of days, report that, record it, and then put it into a system. When researchers are attempting to understand some particular phenomena, such as the effect of a medication on a blood pressure, they might run a controlled experiment. In a controlled experiment, subjects are given some treatment while other subjects are not. The subjects who are not given the treatment are referred to as the control group, or the group in which a comparison is to be made against. The treatment group is the group that we are examining to see if the treatment has provided a statistical difference against the control group. This treatment is also referred to as the variable of interest in the data collected. In medicine, we'll use experiments to test subjects' reactions to effectiveness of, say, vaccines or medicines. In business, researchers will study various topics in areas such as consumer behavior or information economics. We might actually bring students into a behavioral laboratory, conduct an experiment, say, with auctions, where some are given the ability to communicate with each other and others are not given any information. One would be one group, the other would be the treatment group. Data is collected between these groups, and then the results are analyzed to see the performance of each group. There are a number of problems that arise when trying to collect data that researchers and analysts need to consider when they do this. First of all is time. So depending on the analysis, it may take quite a bit of time to collect enough data. There could be a trade-off between how much data can be collected and the time it takes to collect all the data. If you don't get enough data, the results may not be adequate. But if it takes too long, then the data might be stale, which will lead to other problems. Another one is cost. Getting data from external sources may not always be free. In addition, experiments in human subjects normally require a payment to the subject for their time and participation. Next, you can have errors in the data. No data set is perfectly clean, no matter what anyone tells you. I've seen companies talk about how great their data is. We look at the data, and then the data is not as clean as they think it is. But the errors can arise from a number of different sources. Manual data entry can cause problems. Data transmission errors can also change values, and survey studies or experiments can be compromised due to bias or other factors. So there are a lot of things that need to be looked at when you take a look at the data in order to begin doing the analysis.